You can hear us?
Yes.
So maybe just one more minute.
Sure. Start now or?
I think this just one more minute.
Sure.
Sometimes it takes a while for Teams to let everybody in.
Great. That's right.
It's 29 minutes too. I think we can start.
Okay. Right. This is the last talk for the lightning talk for today, and it's gonna be around the topic of AI augmented discrete global grid system, Ai-Dggs. That was a pilot back in 2025 in OGC. So if I want to go into this topic, I just need to always give an introduction to what DGGS is and the why and when about the DGGS. So why it was important at the time and why it's more important these days. And then I'm going to talk about the synergy between the DGGS and AI. And I'm just going to show you the link for the website of the Ai-Dggs pilot, which I strongly recommend if you had a chance, take a look at it. And the future work is the main topics of my discussion for today, really. So for the introduction, DGGS is basically a grid, and basically it's an indexing system for the whole planet. And it's global, so the name is it. So it means that it has to cover the whole planet. It doesn't have to be missing anything. The important part is that it does have a hierarchy. It has a numerical order that describes this hierarchy, and there is a refinement levels. So meaning that there is a zoom levels that goes in and out. If you want to put it in a simple ways. The other side of the story is the zones. So instead of cells, we kind of love to call them zones in DGGS. So they have, each one has a unique identifier, and that unique identifier makes them basically DGGS. So a DGGRS, which is actually the more proper word, but it's not used, is basically a DGGS plus a ZIRS, which is the zone identifier reference system, like a system to define what's that numbering format and order is, and a deterministic subzone order. So it means that every time you mathematically can find what is the children's of this parent, and basically that's DGGS. So the shape can be different, but the so many things about this can be different, but it has to basically cover these basic things and more, of course. It has been there for years, since 1500, really. It even have from the Platonic solids, the idea goes back to 500 years or more. So it's nothing new. This is like, just want to highlight that. Maybe in 1989, just we started to have more of a, applications toward what we are calling DGGS today. There is a history to DGGS in OGC, and that is for past 10 years or more, actually 11 years now. So it started 2015, we had the specification, first edition of it, and maybe the most important one was the 2021, which the OGC abstract spec, topic 21 was released, 2025, when the API was released, and the OGC API, OGC Ai-Dggs happened, which I think it was a kind of a milestone in so many pushes that has been to DGGS. Of course, there were in between federated marine SDIs, had few pilots around the DGGS, and also we had it in code sprints as well as a part of the focus. Where the standards stand is, right now there's 5 parts to DGGS. The first part is the core reference system. It's an ISO document. The Ai-Dggs pilot completely covers that topic. The part 2 is the 3-dimensional, basically equal volume. So the part 1 is the equal area. The second part is equal volume. And the third part is a spatiotemporal, which means that the time is also involved. These are in early drafting, so not there yet. The most advanced one right now is part 4, other than the ones that are published. And the part 4 is the axis aligned reference system, which is in basically advanced drafting. So maybe the edits will be done and will be published at some point, or will be discussed to be published at some point. And the last one, part 5, is basically JSON encoding that is not yet even started, and there is no ISO for it. OGC API has been released and has been mainly was a main part of the focus for the Ai-Dggs pilot. And the other part that is, I'm going to highlight, it's important, and it was highlighted multiple times, is the registry of DGGRS. And the reason for it is that the DGGS has gone beyond the standard, and the reason for it is Uber. So Uber is one of the main users of this. They provided a library, and that library by itself might not be conformant to what we call DGGS. So there is a need for this registry to be in place, so we can all talk the same language and walk the same walk. So why DGGS? It's a projection problem. So the traditional GIS systems are rooted in legacy paper maps, flat maps. These days we have computers. We don't care about that. We can have that 3D nicely presented on our phones, laptops, tablets, wherever. So the distortions that existed, especially that you can see in this H3 representation of Earth, you can see that the cell sizes should be the same. So those cell sizes are equal, semi-equal area. But you can see that they're very much like stretched at the North and the South Pole. So that's a problem that the DGGS plans to resolve. Another issue is the calculation. Why really we have the DGGS and why Uber used it is that, imagine in a city, in a block of city, you want to get an Uber. If it was the original way, you had to do, let's say it was 6,000 cars. It has to do like 40 to 60 milliseconds for the calculation to basically find all the distances. Now you can find your local zone, so you can just get the idea of your place, and you have the idea of the same cars that are in the same zone ID. That would be 50 to 140 cars, and that will reduce it to 1 to 2 milliseconds. So that depending on what zone levels you are going in or you're going out, that could be really fast. So DGGS, that's one of the main reasons that it was used, but now we are even beyond that. And why behind that? Because of AI. So AI gave DGGS another basically force for becoming an important standard for our future. So it's a multi-resolution analysis using DGGS zone hierarchies. It's given. It has the integration of multiple data sources because you can have different data sources in a similar grid, and you can do that calculations very, very fast and effective. And you can have efficient querying and localization for AI-powered applications. And so DGGS can be a foundation for iterative content stores. We didn't touch this one in the pilot. So the ones that are bold are the ones that we really touched in the pilot. Interoperability across data sets. So we use multiple sorts of data sets. You can take from the climate data, from satellite imagery, topography, all the way to even like the human related even stuff like the census data. And you can have a federated AI model training that we didn't touch. Enhanced disaster management, decision support via Ai-Dggs synergy. That was one of the main focuses and the main use cases for our pilot. So DGGS by itself is just an index. So why it can be used for AI and how it can be used by AI is these two tricks. One is that we have to give it a context engine. So the special conscience for grounding in AI. So you have to have a descriptive grounding. AI reads the actual DGGS cell values, and summaries are factual and auditable. But this grounding, it has to use, we are using RAG, the retrieval augmented generation, that prevents basically from hallucination. It provides basically semantic enrichment as well, so stack extensions, and it's very useful for machine learning. So I talked about the context engine. Now I have to talk about how you interact with the DGGS automatically. So if you want to feed the AI and you want the AI to really understand what you're doing. So MCP is the model context protocol, basically goes and reads your API. It understands it, it does the queries, and it basically does the connection. So one gives the context, the other one gives the understanding of the communication. So it basically becomes a self-describing infrastructure. So you ask where is the flood risk? It asks the query, the AI agent communicates with the server stack through the MCP and repeats these actions. And that's the tricky part, because AI loves to do lots of queries, and you do not want that to happen. So that was one of the challenges that we figured out, and we kind of resolved it throughout the pilot. I cannot cover all the topics that was covered in this pilot. It was a huge pilot, so I'm just gonna pass. So the other part that I really want you, if you are really interested in this pilot, go to this webpage. So it is the Ai-Dggs pilot. Just do a Google and Google for Heartis. So this basically summarizes what happened in the pilot, and it provides the link to the servers and the clients that were working on this pilot. And it's an amazing resource that describes basically all the details that is necessary to understand this pilot until the engineering report comes out, which this webpage also provides the link to the engineering report whenever it's published. So the empty page is there, the link is not working. Oh. Sorry. Yes. Okay. So now focusing on the future work. So what we figured, so Ai-Dggs, it does need a standardization roadmap. That was one of the highlights. So the vision is we have to evolve OGC standards from a passive data retrieval protocols into active frameworks for geospatial reasoning. So we need a paradigm shift. We need to move beyond the chatbots to really geospatial analytics. So something that we touch the surface of it, but we're far away from it. But at least we tried, and it proved that it's possible and workable. So the goal is establishing OGC standards that enables basically autonomous AI discovery, and that allows for a seamless machine-to-machine interaction at a global scale. So you don't want a chatbot. You want a machine to talk with another machine, basically. Operational impact would be transitioning from the human-driven queries, right? So that's the whole idea. Another thing is the strategic goal that we have. There is an implementation gap. So we have to ensure that an AI agent requesting an ARD, an analysis ready data, receives identical mathematical response. Like you cannot have different responses with different small queries. Even your queries are similar, you should get very similar answers. And that should be in a federated network regardless of the vendor. And regardless of vendor is also another important part. So we should not rely on Esri's or ArcGIS's of the world to always provide this services. So we have to have this sorted out. We identified some core pillars for it. So the geospatial grounding that I already mentioned, we touched, ensures that the AI logic is actually anchored on the physical reality. There should be a multi-grid interoperability because so many grids exist and data providers might choose different grids based on their basically specs. But the API theoretically should support conversion between any DGGS grid to the other. So hopefully that will happen. It's, partially happening. So provenance-backed mapping, we have to create a traceable chain of evidence from the source of the data to the AI conclusion. We actually touched based on this topic. We had a common operating picture as a part of this pilot, which really went deep into the concepts of integrity, provenance, and trust. And we had basically a very interesting work on this that is covered in the pilot. And I strongly recommend, if you are interested, look at the ER when it comes out. So the main roadmaps. Number one, we need an iterative DGGRS register. So the problem is that there is no central registry for DGGS. We need something like the EPSG that codes for map projections. Talk the same language. Otherwise, it's just not going to work. The second one is the discovery-oriented API extensions. So the problem is that our current standards require clients to know a specific technical zone ID. And what we normally users want is that they want to give natural geography, lat and long, and get their results out. So that, because of the complexities of DGGS and its specification, is not that straightforward. So that's something that might be of interest in short time to do. Another one is the OGC best practice for H3. So H3 is the most dominant format library for DGGS. It's used by Uber, and because of the tooling that exists, everybody uses it. So, but H3 has a conflict basically between the industry standard H3 library, which is a spherical and aphelic, and the OGC standard, which is based on ellipsoid and WGS84. So we need to basically publish some definition that will explicitly resolve this issue, and we need to actually do this very, very fast. Because if we do want to the DGGS to be interoperable, we want to make sure that the people who use that library know that if they don't use it properly, it's not going to be interoperable. It's going to be a waste of money, another silo of the data. So the other topic is the 3D and spatiotemporal regrading parameters. Yes, that's part 2 and part 3. So satellite passes are irregular and occur at inconsistent time steps, making temporal data fusion difficult. You have inundation on, land and sea interface, and basically you need a 3D equal volume representation of the grid. Otherwise, it's just useless. So our DGGS at the moment are basically a 2D extension. That's what I call it. So the 3D volume and the spatiotemporal, which is the part 2 and part 3, has to be done and has to be released. So that's that's one of my focuses, at least, trying to figure out how the part 2 is working these days in the code sprint. So the benefit would be allow the AI to synchronize basically disparate data sources across time without the bandwidth penalties or complexities of basically traditional sparse data formats. So that's very important. Last, actually, one before that, that's the one before last roadmap, is the common operating picture. So the vision is that you have to transform the OWS context into a machine-readable JSON schema. So we kind of started to touch base on this. So integrate the ideas of this IPT framework, provenance and trust, which is integrity, not identity here. I copied this from Stelius. I have to fix that. But so the benefit is that ensures that every AI generated map is not just a visual, but a verifiable document that communicates its authoritative sources and data lineage to disaster coordinators. So we had this pilot supported by NRCan, and they brought us the use case from Manitoba, and we had the long discussions with Manitoba folks, that what is needed from their side, and they were very skeptical on using AI. So if you don't have an authoritative solution, it's useless. And we kind of did a very authoritative results in this pilot. We couldn't tested it, but it seemed very authoritative because we did have the basically grounded the AI. We had controlled over the data that we were feeding, so on and so forth. But I'm thinking that in the future pilots, we definitely have to have a measure of how authoritative we are, so we can prove to users that this can be used in even a very difficult scenarios. The last roadmap is advanced analytical extensions. So moving DGGS beyond the storage format to basically a computational environment. So yeah, custom aggregation, that's the biggest challenge. Where do you do the calculations? Are you gonna do it in the server? Are you gonna do it in the client? Is the server of the DGGS should do just more than providing a grid? This is sometimes a philosophical discussion, so I'm not too sure we kind of agreed on what's the final answer to this. I think it's a use case based. So yeah, so some of these topics we touched just surface of it. Some of them they have to do it in a later time. So like direct zone statistics, which would be returning basically min-max average on the area by the server, like cross collection queries, like aggregation. So yeah, these are some future work. This is a copy paste from the web page. It's a basically operational alignment matrix between what we think this future works are and what solves by the DGGS friction and what activities on AI needs to support in future. So it has a color based, so you can see the technical frictions in pink, the engineering tasks in blue, and the research, which means that you're far away from it, by orange. So yeah, so I just wanted to highlight that, for example, formal best practice for H3, which is the most needed, is basically on the research side. So okay, I'm not gonna take more time. I'm just gonna ask you guys to go ahead and ask your questions if you have any.
I have one from here.
Yes.
Well, I have two from here. If I understand correctly, the activates AI from here, how is it related? Like, how the two columns, is one going to solve, like, the AI is going to solve?
So it needs both parts to be solved for that issue to be solved.
Okay. And what is the semantic interpretation gap?
semantic metadata, that's the interpretation gap. Yeah, so what you have is that this supports different data sets, right? So the DGGS can be roads, can be whatever, right? And these data sets need very, very solid metadata for the AI to understand it. So that gap exists. We actually, this is beyond this pilot. We did an open science persistent demonstrator, and we had scientists providing workflows with metadata that we requested. And even till the end of the pilot, we figured that the metadata is not enough for what we want to replicate and reproduce. If humans cannot really understand it, how you expect the AI to understand? So the semantic gap exists. So you need to have common ontologies. You have to have basically talk the same talk.
And I have another, because I got lost with the name. We're talking about the canonical solution. What is Ai-Dggs? Because
Yes,
it was there.
Authentic. It should be in the H3. Yeah.
Ai-Dggs. So I don't know this word.
Spherical dome. Is it a projection?
No.
What it means is it has the same area as
Yeah.
here. So for example, when we use like an ellipsoid, so the like the Earth is an oval spheroid, so there's some flattening. So if we use the blue GS84, and so the blue GS84 has some area. So an Ai-Dggs sphere compared to GS84 it's perfectly spherical, but it has the same surface area as the ellipsoid. And we can do a lot of computations, basically pretending the Earth is a sphere. And then we do a mapping between an Ai-Dggs latitude and the geodetic latitude, which then allows us to get perfectly equal area zones on the surface of the ellipsoid, even though we did the calculations on the sphere. So that's kind of like the Ai-Dggs latitude is basically the it's the latitude on the sphere that corresponds to the
ellipsoid.
The geodetic that will give you the equal areas. It's a auxiliary latitude.
So the conflict between the two is because one is spherical. It's assuming.
It's actually the H3 library is perfectly fine as it is, but it's how you use it.
Okay.
That's and we have a whole section in the ER, and that's all the corrections that we merge once it's going to be published. I think it's a good start for this practice. So what we need, and by the way, the registry is also up, right? We have the DGGRS register is actually GoBay set it up, so it's actually live.
Oh, it's
already
live
there.
now?
It already
Okay.
exists.
It's already there, but it doesn't have the H3 definition yet. So what we need to do is to define the H3 definition that includes these clarifications. And we actually need two. One for the people who use it the way most people currently use it, and one using it the way it should ideally be used. And the good thing is you can know which one you're using, because if you think you're using it one way, but you're using the other way, you won't align. But it doesn't matter which way you use it. There's a better way to use it, but you have to know which one you use. So by having either one or two definitions, so that's a decision to make, I guess, whether we want to define both the correct way and the slightly less correct way, but at least you could say, I'm using this one, and this way things are referenced correctly, right? Because otherwise you don't know which one you're using. And part of the problem is in the documentation of each tree, they talk about the Ai-Dggs sphere. And so you think from this that you're doing this conversion, but the library doesn't do that conversion, and the users probably don't do that conversion either. So the documentation, the way it's phrased is very confusing. So it's clarifying these things, and having these definitions will clarify.
So the library does not support those that basically.
Well, the library doesn't care. It's not that it doesn't support it. It's that if you give it whatever latitude you give it, it basically it treats it like you give it an Ai-Dggs latitude.
Yeah.
But if people probably give it WGS84 geodetic latitude all the time, and it just pretends, okay, that's an Ai-Dggs latitude on the sphere. But yeah, there's a lot of, and one of the other complication is that the way that the zone edges are defined, it's basically, it's a great circle, it's a great circle arc on this internal italic sphere, but it won't give you like intermediate points in between. So it pretends that it's a arc on the great circle, one or two for edges, depending on whether you cross the boundary or not. And if you then do the conversion, well, it's not the great circle on the ellipsoid, and it's especially not a straight line if you're on the Web Mercator projection, which is even worse because people will draw the hexagon and they'll just connect the dots on a straight lines, and that's not what the real zone segment is. It's a great circle on the internal italic sphere. If you're using the actual ellipsoid, then you actually need extra points. So yeah, all the details are in the annex about that. And that's what, I think we could take that annex and prepare best practice, or at least inform that definition that we can register.
So I think,
Of the pilot?
The
Annex of the ER,
that's
the
an
report.
But it's not published yet, right?
No,
so the issue is that.
but if you are a member, you can access it.
So.
Yeah, I think it's in the GitHub.
Yes,
The GitLab.
The GitLab.
GitLab.
Someone asked me if about the policy.
I connected him
You connected with
with
him.
Rosie.
So can we share with anyone, any existing member on Agora? Can we just point them directly to?
Are
the-
they Agora members? Are they?
Well, if they're on Agora, I imagine they're
They're
Yeah.
OGC
Yeah.
members, right?
Yeah.
Is it okay, or they need to sign a sort of
They
agreement? Because.
have to enter it was in a test bed or?
Yeah.
That's been-
So
They need
you
to-
have to join the test bed and then you have to go
It's-
into the menu to request the GitLab access.
Right.
That's. what
It's the same as the SWIGs and DWIGs. You have to go to the activity, you say, I agree.
Yeah. exactly.
And after I agree, they can join the GitLab.
Yeah.
But I think that's, Scott will kill me if I say, yeah, you share it. No, you shouldn't.
Okay. So because sometimes like if it's posted to pending documents, then everybody see it.
Yeah, it is posted to pending
So
documents,
that's
but
what-
it's not the latest version, right? So the latest version, that the parts that you have added is not in the pending. Yes,
Because it's a public link, like the.
yeah,
actually-
yeah, the pending document is a public link, but
But any OGC member can go into the GitLab.
yes, but it has to accept
Oh, yeah.
the, the conditions and just have to go through the steps to get.
And it needs to create a
Absolutely.
GitLab account. Yeah.
Slightly related, a little bit off topic, but then I cannot join, for example, we were talking yesterday about the testbed 20, but that's not longer available.
Tezbed 21 or Tezbed 20.
Just the 20, the one
Oh,
previous.
Tezbed 20, yeah,
So
yeah.
yesterday we were talking about
Yeah.
something that, two changes.
Just email us, Gobe, me, Greg,
Okay.
and we can definitely
Because
provide you
21
with
is
the
there,
access.
I put access.
No, it is there, but since that we have changed the platform, you do not, they are not uploaded to the same system. These are the current activities, so they're connected.
All the reports from Tezbed 20 have been published, so.
All the, yes, all the testbed 20,
On the website.
yeah, they are published and they're
Okay.
public. Yeah, but don't know. But some of our old activities are really hard to find. Well, they're all. there you go.
They are public, but the website
Yeah.
only displays, I think, starting from Tezbed 19 or something.
Yeah.
But the links are public.
Mhm.
I mean, there's a 1 GB file, decent file with links to all the documents that were published. I can point you to where it is, and it's actually on the naming authority register. But
Oh,
that's one way to get the URLs to the documents.
So
I
getting
posted the links in the chat.
to the problem there, the conflict is more like a lack of documentation around which, what it means exactly. H3.
So H3 has a library, right? It's a
Yeah.
everything. Our DGGS, in order to be interoperable, needs to have certain parameters. Like you have to consider them, right?
Okay,
So those have the person who uses H3 can do whatever they want.
Mhm.
And
But they
that's,
cannot expect it to be.
yeah, and that you would not expect this to be really a DGGS. It will not be interoperable. At the end of the day, you might have data in that, I mean, whatever you have written, and then you could not use the DGGS, I mean, capabilities, the real libraries capabilities to maybe convert from one grid to another grid and have errors that you don't even know and you assume that they don't exist and you don't even care about it. And DGGS is a very complex system. It's for a global core. It's a global basically system. So all the issues with the distortions and stuff can be really, really big, right? He mentioned that. Like they can be super big if you don't really know what you're doing.
That's exactly because you have to know what you're doing.
Yeah.
Because there's some ambiguity
Yeah.
in how the library can be used.
Yes.
So people can use it, like the people who maybe know more about this might use it in a way that actually is not how people who know less about this will use it.
Yes.
So, and that's where the ambiguity is.
It's like having a non-type language.
Yeah.
And then going to a type one, and if you want to get the same code, you have unfortunately you didn't have.
Oh, cool. I found a smaller file. Sorry. I mentioned a file that has all the listing of the, yeah, I found a smaller one, only less than 2 megabyte size.
I think we were seeing how to produce this data.
So I'll just share it via chat.
Is there any question online? Don't see the chat anyway. Is there anybody in the chat?
There are no questions online. So, but I've got a question.
Yes.
So what's next in terms of, because right now we're thinking about, ideas for the next series of test beds. So where do you see this Ai-Dggs concept going in terms of, the next test bed? What could be done? Or let me get to the next initiative.
One big interest is the basically access aligned, which is not covered in this pilot because access aligned is a complete different beast, right? But the specification is out. I mean, the specification is almost done. I'm not too sure what's the
Some of the DGRS we use are access aligned.
Yes, some of them are R.
Some of
R
them-
stands for rhombus, right? So R or
The
D.
rhombus and the so
and the D's.
Okay.
all the heel picks are heel picks, the closest local grid, all the R1s, so all of those are actually it's just the hexagon and the triangles and the pentagons that are not. If your shapes are quadrilaterals and essentially and they're all axis aligned basically.
Right.
So one avenue that I can see it's coming soon is Gers and the Japanese one, which is a spatial ID.
Okay.
So like they have this IDs for the box cells, basically saying that I can give ID for every desk on basically the whole building, right? And that can, if touched, they can really have some sort of a conformance with the access aligned DGGS. I'm hoping that it will be possible maybe for the API to convert, I mean, basically to make that a special ID with the DGGS I'm not too sure if they can use that as a ZERS. Can they?
Like the only thing with this special, if I understand, basically they're using Web Mercator and they're cutting things as files. So the problem with that is that it's not global because Web Mercator and
Exactly
5 degrees. So they need to come up, if they want to call it a DGGS, if they want to include the G, that means global, they need to find a way to map like something that goes all the way to the poles or something, just to make sure it's global. And then it becomes global.
Yeah, they're working on some sort of.
But I think they're discussing something, a
Yes.
solution for this.
Yes.
So I think it will be in Helsinki.
What were they like? machine learning or even deep learning demonstrations where you basically had the DGGS as like the framework, and then got a whole lot of columnar data mapped or reference to that DGGS. And basically, I'm picturing like a, multi, if not hyperdimensional space, and you've got right at the bottom there, you've got the DGGS, and each of those cells basically providing the reference to the ground, but being able to feed as much data as possible and over various, and then applying machine learning algorithms for whether for classification or categorization. Basically, I'm just wondering what applications we might be able to do with this from an analytical basis, especially with deep learning, as you can do it.
Bear with me for a second. Let me share my screen with the online folks as well. Show you. Okay, so this is the pilot's website, and it describes so many things, and the challenges, what was the data that has been used, the architecture, the descriptions, and it goes and goes and goes till we get to the servers. So these are the servers who were providing the data. Each one of them has, as you can see, different pictures. And then you get to the clients. So these are the clients. So each one of these have implemented basically, and you can launch their AI dashboard. And each one had a different focus. So CS Group is the one that used the most data, like try to use as much as different data sets possible. So different grids. And you can see that they have some description of what that is. The ones in between are in between. The most advanced one is the Heartist. So the Heartist, they came up with this basically index for flood.
Right.
And they were using different data, and they were querying based on this format that it was calculated behind. And based on that, the AI was giving you interesting information, like which roads gonna be affected, which hospitals might be on the in the inundated area, and it was not like a pre-written question.
Yeah, exactly. Yeah.
So
it's really good.
Yeah, but there's no really machine learning in that sense that happened. We didn't invent to that far. Like the AI was doing its job, right? So we really didn't do anything that I would consider that machine learning.
Did they say what AI, the platform, or what AI capabilities they were using underneath?
Everything is written there.
Right.
Everything is written in that pilot. It's very, very detailed. And Terraframe is actually one that I suggest that you really look at, because another alternative solution and we thought originally that might be another alternative solutions was knowledge graphs.
Yeah.
But we figured that the DGGS and knowledge graphs are actually complementary in this sense, more than competing against each other.
Yeah.
So adding knowledge graphs to the DGGS, to this AI bunch, will basically make it even more.
Yeah.
One more thing that we did in the later phase, after the pilot technically, and that because all of these discussions at we're having discussions at the meeting, the demo days. So I've started to implement something where basically it's like a vision transformer mascot encoder that I implemented from scratch, where it basically uses the DGGS subzones as the tokens.
Okay.
And basically you have your big zone, your data packet per zone is like your batch.
Yeah.
and then your subzone inside, which has the data value, elevation or risk or whatever, and it treats that as the tokens for my transformer basically, and this gives you and you can have different data sources and you can do data integration, and then you can do like prediction of like I hide this, so what should be here. So that's the kind of thing we implemented. And I haven't really, that's not in the ER, and it's just a very high level overview of this. I still hope to publish this in a discussion paper or something, but that's also interesting.
Yeah, I think that's like what's the right phrase? Low hanging fruit. You know, something that could be implemented and exploited in terms of leveraging it quite. I'll use the word easily, but I know it's not an easy thing to do. What I mean is that it's feasible, right? That's a better way to phrase it.
What is the key thing about this was the generalization. So sometimes when you build it, because the idea was very aligned with like a geo foundational model type thing, and the idea is to make it basically agnostic of the scale and the region, so that when you train things, it like and I figured out how to do this association and how to set up the model. In such a way that you're not really tying it to the location, you're just learning from the context, and whether you're dealing with very small zones or very large ones, it's learning from all this. So it's very interesting. Yeah,
cool. Yeah, so there's quite a few things that could be done in future.
We just really touched the surface.
Yeah,
I think, but my personal preference is that this pilot was successful because we had a clear use case. Any future pilot that has to be done on this topic has to have a very concrete use case with data that is available prior even to the pilots, not that we have to look for it. And this pilot had the data because NRCan was supporting that.
Okay. Cool. All right. Are there any questions for Sina online? From the room? Yes. Yeah, sure.
Thank you so much. That was really interesting. So I just wanted to ask you, can we train this kind of AI models for specific industries? For example, in construction industry, we have some beam data, and we can train those AI algorithms to understand what kind of data is important for us. And then they can, enrich those kind of data for those kind of IDs that you mentioned for your future pilot. So it could be very good because beam modelers are already doing this. And the difference between beam modelers and 3D modelers is about the information that they are adding to it. And if your AI models can, replace this kind of data, that would be very good for your next pilot.
So we actually discussed this as one of the future works. And at the time when we started this project, MCP was out, but the Skills was not out. So Skills is another library by Anthropics. It's open source. You can do whatever you want with it. And that is basically exactly what you want, because you train your data and you train the skills based on your specific domain of work. So we didn't have a chance to use it because, as I mentioned, it was too late to have it. But so we haven't tried it, but I don't see any reason not to use it. So so I would say that look at agent skills.
Yeah, great. Thank you so much.
At least that's my opinion.
Cool. Any other questions or comments? Okay, if there are no other questions or comments, let's thank Sina for a great talk. Thank you. All right. So I think that's the last one for today. And then tomorrow is the final day, and we'll have
Quite a number.
quite a number of them. I think most of them are based on OGC API connected systems or are about different aspects of OTC API connected systems. There is one on WebVMT. But yeah, so it should be another exciting day.
I think more than lighting, was there a lightning?
That's true.
Yeah. So here, the answer to your question is here.